Hello, everyone. It's great to be here. My name is Martin Eichenhofer. I'm the CEO of 90 Labs. I want to kick off this presentation by a short excursion into fiber composite materials. It's usually associated with aerospace applications and being lightweight and strong like metal. But there are other unique characteristics to this material, like being thermally stable, having a low coefficient of thermal expansion, or being X-ray transparent. That's interesting for medical applications, for instance, or in general, we can say it's quite chemically resistant to material. So there are quite unique characteristics that make it applicable for a lot of different industries and application fields. But now we can ask ourselves, why is it not as accessible as ordinary metal materials in particular for series production? And if we take a look into the manufacturing world of fiber composites, we see that there's a certain degree of automation, mainly from those automated tabling and fiber placement systems where they're really intended for large scale, really thin kind of shell-like structures. And they also usually associated with a high investment cost. So, but still the gross and the majority of all the parts in the applications, in particular the small applications, rely on hand layups, so manual labor, where we have limited reproducibility, we have limited performance because we are using fabrics. That's the only way to handle manually those millions of fibers. And we have a high material waste because we have to carve out the geometry out of those fabrics. And in general, we can say it's quite time consuming and expensive to produce parts. Newer technology fields like 3D printing, and I'm talking here about continuous fiber 3D printing, is kind of destined to fill that void, in particular for smaller applications, more complex geometries, but it's not the mature technology yet. So we're lacking sophisticated simulation and optimization tools, we're lacking the right structured composite materials, and we're lacking basically the final part quality. And I think that's really the most important part for me, because the final part quality defines if you can go into series production, if you fulfill those quality standards. And if we take a look at the global part manufacturing market now, 3D printing and composite manufacturing technologies were believed and are still believed to capture a significant portion of this global part manufacturing market. But looking at the chart, we see that they have not really fully realized their market potential yet. And that's mainly because 3D printing was focused on niche market applications, and composite manufacturing is lacking next generation of software and automation. And that's really gives us a unique opportunity to combine those two technologies to get the best out of both worlds. And that's what we see here on this slide. So what we are doing at 90 Labs, we are combining the high performance composite materials with 3D printing technology, which gives us the automation aspect and which gives us the next generation of software, the optimization aspect. And we pair it with conventional composite manufacturing technologies, which gives us the high reproducibility, the low porosity, good interlaminar bonding, good surface finish, high tolerances, etc., which are really a necessity to go into series production. And this unique combination really enables us to fulfill that market promise, which we have shown on the slide before, and accelerate the adoption of 3D printing and composite materials. Our solution based on this concept is called the RED series. It's a solution, it's not a single product. So we have industry grade materials, continuous fiber, high fiber volume content, so 60% fiber volume content. We have the software, which is really a software platform where you have FEA tools, so simulation tools integrated, and where you can also, that's important, it's not just about optimizing and finding the most optimal design, it's also about digitally validating the part before you then go into the physical world, which is then the build module and the fusion module. In the build module, that's where you print the part. We call this actually a preform part at the end, and you insert it into the fusion module, which is this compression molding step, where we apply temperature and heat to increase the quality of the final parts to make the part fulfill all the standards and the requirements for series production. And that's again what I want to emphasize. The technology is built for series production, not one-off parts, not mass customization parts, and it's really intended for structural components, so load carrying structures. And the way we offer the technology is in a subscription. So we have the subscription bundle, which we call the RED series, which is comprised of software, hardware, and engineering services. And we also have maintenance, software upgrades, technology upgrades, hardware upgrades, integrated all into this one bundle. And the intention is really to go with the customer quickly from an idea to a final series production part. I think that was it. This was just a short introduction. I'm really looking forward to the panel discussion and really also talk more about application fields, industries, etc.